To Algebra 2, Lesson 2-4, Complex Numbers and Operations, Example 2. Before we move on to Example 2, we have to talk about this concept, complex numbers. So the imaginary unit I is the principal square root of -1. So if we know that I is equal to square root of -1, we know that I square would be square root of -1 square, which is going to be -1, right? So keeping this in mind, we're going to define imaginary number as any number bi, where b is a non-zero real number and I is the square root of -1. Okay, so 2i is an imaginary number. 3i is an imaginary number. -1/2i is an imaginary number. Okay, so anything that comes with an I will be an imaginary number. Complex numbers are numbers that can be written in the form a plus bi, where you have these two terms and their sum of a normal number, a real number, and another real number times imaginary number, which makes this an imaginary number, right? The imaginary unit I, whenever you see the imaginary unit I, and when I is involved, it is an imaginary number, and this is the imaginary term. Okay, so a and b are real numbers, but I is the square root of -1, which is imaginary. And so they include all real and imaginary numbers for complex numbers, as well as the sum of real and imaginary numbers. So for example, imaginary number is a part of complex number. Okay, and sum or differences of any real numbers and imaginary numbers would be complex numbers as well. Okay, so let's look at example 2. We're going to add and subtract complex numbers. How can you add and subtract complex numbers? So for example, in part A, let's look at the sum of 4 minus 7i and -11 plus 9i. In this case, whatever we can add together are called like terms, right? We talked about this and you probably know that, right? When we first learned polynomials or quadratics, right? Or even like equations. So you should be familiar with like terms. For complex numbers, they're like terms with each other. So you can add the real numbers together and you can add the imaginary numbers together. And that's easy because you just have to add the coefficients for complex numbers, okay? So you're going to group them together, rewrite them with the like terms, and then add them together, and that's it. You're gonna end up with complex number. The differences work the same way, except you just have to distribute your negative. Just make sure you do that, and then you're gonna add the like terms again, and then simplify. That's it. Okay, shouldn't be too hard. So let's try number 2. Find the sum or difference of these two problems. Pause the video and come back when you're ready for answers. Okay, are you ready? So part A, you're going to add the like terms. So -4 minus 2 plus 6i minus 9i should give you -6 minus 3i. Part B, you're also going to group them, but remember distributive property. 3 plus 4 minus 2i minus I will give you 7 minus 3i. That's it. Wasn't that easy? Okay, now let's move on to the next example, example 3. Multiply complex numbers. How can you write each product in the form a plus bi, which is a complex number form, right? So part A, we have a complex number times a complex number, right? -2.5i times 8 if you use the distributive property, and then negative 2, 5 times negative 9i will give you negative 20i plus 22.5i squared. I squared will be a real number, so you need to simplify that. I squared would basically be negative 1, right? So then 22.5 becomes a negative 22.5, and put the real number first because that's how your complex number is formatted. And then you're going to write negative 20i. Okay. Part B, you're going to multiply the binomial 3 times 3 and 3 times 2i. And remember, you're going to multiply negative 2i with 3 and 2i here. And then use the distributive property, add the like terms, and you're going to simplify. So 9 plus 6i minus 6i would just be 0. And then if you simplify, it's beautiful with a real number 13. So sometimes you can cancel out your complex numbers. That would be great. And you can make the I square real number. That would be great. Sometimes you still have a complex number, but sometimes you end up with having a real number. So just make sure that you use the distributive property well, and that's all you gotta be careful with. Okay. Let's try number 3. Write each product in the form a plus bi. 2 over 5i times 10 minus 5 over 2i, and b is 1 over 2 plus 2i times 1 over 2 minus 2i. So pause the video and come back when you're ready for answers. Okay, are you ready? All right, so part A. You're going to distribute 2 over 5i to the binomial, and you get 2 over 5i times 10, and then minus 2 over 5i times 5 over 2i. Okay, and then if you simplify that, you'll have 1 times I squared, which would be negative 1, right? And so negative times negative 1 would just be 1. So you have 1 here, and then you have 2 times 10 divided by 5, or you can simplify like this, multiply 2 times 2, you have 4i. And so your final answer should be 1 plus 4i. Part B, you're gonna distribute using the FOIL method, and you have 1 over 2 square, and then you have negative 2 over 2, which is 1i. 2i times 1 over 2 would be plus I. And then 2i times negative 2i would be negative 4i squared. So this cancels out, and 1 squared would be negative 1, so that becomes positive 4. And so your final answer should be positive 4 plus 1 over 2 squared, which is 1 over 4. So if you add them, you're going to get 17 over 4. And that's a nice little real number. Okay, so for part A, it would be 1 plus 4i. And for part B, it would be 17 over 4. Check your answers, and if you got both of them correctly, good job. All right, so that was examples 2 and 3, multiplying complex numbers and adding them. We're going to continue with the next example in the next video.